in the field using things like profiling. And you can also use things like, employ techniques like statistical testing once you get profiles, and you can also do things such as capture replay. So you've got a bunch of user profiles, right? You sent your software out to users, you instrumented it for profiling, you've got mounds and mounds of data back from them. So what do you do with all this stuff? Well, one thing that you can do is you can cluster your executions. So this is a picture of JTidy executions. JTidy is a pretty printer for HTML written in Java. And what my lab did, my good friend Pat did, was take the executions and cluster them according to similarity. So these are function call profiles clustered according to similarity. All these ones in this blue cluster here had similar numbers of functions, well, had functions called similar numbers of times. So, you know, function A was called 30 times, function B was called another number of times. These are all very similar. And you can see that they're very distinct. So this is useful in order to visualize what people are doing with your software, what's going on in there. So let's say that this pink cluster here is full of failures. I know that because all of these executions are similar, they're probably failing because of the same bug. And even, you can take this a step further. If you get a new execution profile from the field, you can put it into the cluster. You can put it into this picture and say, alright, where does this go? Maybe it goes into the pink cluster. And you can say, oh, this is probably a failed execution caused by the same bug as those. We already know about this bug, so this isn't a great big deal. This isn't anything new, you know, we're working on that, we're fixing it. Maybe you get a failed execution that's, you know, off in this corner over here. Maybe it's a new bug, so you should look at it more closely. So one way to use clusters is to figure out which failures are related. So you have a bunch of execution profiles. Some of them are of executions that failed, you know, maybe it crashed, maybe something was the wrong color, maybe somebody missed an HTML tag, maybe JTidy printed it out wrong. Failures can be different for bugs. So one bug can cause a bunch of different kinds of failures, right? Maybe the same bug caused the crash as caused the missing HTML tag. So when you cluster your failures, you can figure out that, yeah, these look different on the face of it, but they're actually caused by the same bug. You can figure out which new failures are caused by bugs we already know about, like I said. You can figure out which bugs are causing the most failures, statistically, over your group of beta testers using your software. So you have maybe 10, I don't know, maybe 100 beta testers using your software, you've got 1,000 failures. You know that 3 bugs are causing 80% of those failures. That's a good start. You can concentrate your effort on those 3 bugs. And you can figure out what profile data those failures have in common. So if one function is consistently showing up in all of these failed executions, you can say, oh boy, we'd better look at that one. So another thing that you can do with all of this data that you collect with profiles is statistical testing. So in statistics speak, you can calculate an operational distribution of your profile data. So let's say I have, I don't know, my monster truck simulator, and I've got a function, start engine. And I can say, in all of these executions, start engine is called 1 time by 10% of them, you know, 3 times by 70% of them, and so on. So you know that the majority of executions call this function a certain number of times. And you can do that with all your functions, and in that way you can make your offline tests random over the space of that distribution. That means, what are people actually doing with your software? If one function gets called in 30% of executions, then for statistical testing, 30% of your tests are going to call that function. And this is a good idea because people are going to use your software in ways that you don't expect. That's just a given. Users are the biggest source of entropy in software development. Once you ship it out to them, you don't know what they're going to use it for, and you don't know why. And the way that people use your software is going to change over time. So the research that I do is mostly stuff with compilers, because it's easy to automate input, output, you know, you've got a bunch of C files, you've got a bunch of .out files, you're done. The way that people write C code changes over time. So the functions in GCC that get called in 1997, the distribution of those is going to be different than the distribution of the functions that are getting called in GCC now. And that's just an example of how this is working. So we go from statistical testing to calculating an operation. We've got, you know, a distribution of profiles to see exactly what the users are doing. But this is a way to get a better picture of what exactly the users are doing, because you're capturing exactly what the users are doing. So when you see capture replay in a testing context, usually that means you have a GUI test automation tool. And that means that you've got some software tester somewhere sitting down in front of WinRunner and clicking here, clicking there, typing something in, pressing enter, and saying capture. And they're putting that into a test suite, and so that they don't have to sit down and do that 50 times for their software. That same series of clicks and typing and all of that is automated, and it's going to get run later. What we want to do now is do that backwards. So instead of having a tester say, make the software do this, we're going to collect executions from the field, we're going to capture them in that way, and replay them back at the company, back offline. So when you have capture replay, you're taking exactly what the user has done with your software. You're saying they clicked here, they clicked there, they entered this information, and you're replaying it later so you can see exactly what they did and when they did it. So this is like a tech support professional's dream, right? How did you mess this up? What did you do? I don't know. Now you can know. It's useful from a beta testing standpoint because you can see where the user is floundering. Maybe your interface isn't very intuitive in some way. So they're clicking around, they're trying to do something, they don't know exactly what they're doing. So maybe you can see that a lot of people are doing that and change something around for them that way. And you can also see what exactly the steps were that they took to elicit this bug that happened when they used the software. Like profiling, there's some kinks to work out in operational testing. First and foremost for me is the confidentiality issues. Whenever you send information back to a company, you're sending information about what you're doing with the software and the information that you're using the software for. And so companies may or may not be ethical in what they do with this, and they may or may not be ethical in terms of the information that they collect. I see this as a big problem, and I don't know. It's a big question in software engineering research as to how to solve this and how to make sure that everybody's on the up and up with this kind of thing. Yeah. It seems better to be used in a beta test just because capture replay has a lot of overhead. You have to collect all of these different GUI moves and things like that. So in release software, it would be an awfully big performance hit for all of your users. But if techniques for doing this improve, or if maybe the software isn't, it doesn't matter how slow it is, there are some things that it's okay if it's not exactly real time and people don't want the results immediately, people might leave capture replay in for that. Yeah. Yeah. Yeah, absolutely. I mean, if people get this thing for free as a beta test, then you can ask them to sign their soul away and use all of their information for it. If you're releasing it, yeah. Yeah, if you're releasing it, then there are a whole nother set of issues. Do you have a question back there, or you're just chilling? Okay, cool. So there's the same issues with profiling as well. There's a lot of overhead, like I said. You have to instrument the code for capture replay, or write some sort of capture replay device that you can inject code with later. And it also generates a lot of data that you have to do stuff with. So, yeah. Yeah, it depends on exactly what kind of detail you want. Yeah. So if you want to do everything down to GUI moves and down to, like, the most difficult part of capture replay is getting the threading right. So if you have a multi-threaded program, you have to collect all kinds of information about which threads terminate and do what and when, so that your replay is exactly the same as what you captured. And so that's a lot of information, and that's pretty hard to do, and that can slow things down a lot. But yeah, it does depend on what kind of application it is. So if it's like, one example that I'm thinking of is that somebody used it in a Genie application, which is like distributed Java code. That, you don't want a lot of overhead for that, because you're talking over the internet between computers. Any slowdown is a pain. But if it is something like Microsoft Word, you've got human factors, you know, people are typing, people can only type so fast, then that wouldn't be as bad. Yeah. So now we're getting, finally, to the meat of the talk, which is test selection and prioritization. And this is one of the hottest research topics today. How do you figure out which tests to run and why? It's a big industry issue, and most of the software testing research in test selection and prioritization focuses on regression testing, because regression tests are what gets run day in, day out. Sometimes people are on a continuous regression test cycle. And so if you can prioritize which tests you use, then you can have your regression testing be more effective. So what is this? What is this thing? So you've got your problems, you've got your big test suite, you've got your thousands of tests. You know that some of these are more effective than others. And you know that you have only so many software testers, you've only got so many computers, you've only got so much time, you've got 3 weeks instead of 6, you've got, excuse me, $10,000 instead of 50. How do you make sure that your software gets out on time, tested well? How do you find as many bugs as you can in this limited resource space? So obviously, this seems like an obvious point, you run only the tests that'll be the most effective that time. Oh, great. What does effective mean? So an effective test suite is going to find as many bugs as possible at the lowest cost possible and do it consistently. And that means if you run it 1 week, it's going to find a bunch of bugs. You run it the next week, it's going to find just as many. It's not going to fall off over time. So the way to select your tests is a way to make sure that your test suite is fresh, to make sure that it's finding as many bugs as it can all the time, and to make sure that you get the most bang for your buck from your test suite, basically. So at this point I should mention that test selection and prioritization, you can think of them as sort of the same problem. They're two sides of the same coin. So if you have 15,000 tests, and you sort them in order of which one is going to be most effective, that's prioritization, right? You can say test 1, 2, 3, 4, 5, just run them all, but run the most effective tests first. Whereas selection, you just take the top 25% of those and just run those. And because of the law of diminishing returns, you know, the more tests you run doesn't necessarily mean that you're going to find more bugs. Selection is pretty much as good as prioritization in this way. Does that make sense to everybody? Okay. So the questions you want to ask for these things are, what's likely to expose faults? Which tests are the most likely to find bugs? Or, which parts of the code have the most bugs? Which tests test those pieces of code? Or, which behaviors cause the software to fail the most often? If you're asking that question, then you'll run the tests that go through those behaviors. Which tests exercise the most frequently used features? If you want your program to look great for 99% of your users, you know that 99% of your users use the software in this way, they use X, Y, and Z functions.